This is Algebra 1, Semester 2. It's the 5th unit called Equations Review. It's the 9th lesson called Rewriting Equations and Formulas Practice. It's on creatormath.com under the Algebra 1 tab. As you Google creatormath.com, you might have to Google creatormath.weebly.com. All right, so the instructions to this problem set are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So let's model that quickly for you. So here we have, okay, maybe not. Here we go. So here it is, creatormath.weebly.com. That's how you Google the site. Hopefully you can get to the home page, which looks like this. Please remember that all of the composition book instructions and videos, etc., are down on this home page. Just look for the large words and the picture of the composition book. We're going to go to the Algebra 1 tab. That's where all the notes, video lessons, practice sets, and vocabulary are. Remember that this PDF is a complete PDF of all the vocabulary we're going to use through the entire school year, and it is searchable. You guys, if you don't know how to search a PDF, just Google it, and it will help you figure out how to search on your device. So I want to say, if you're not getting 100% on your vocabulary practices, maybe you don't know that there is a PDF here with all the answers on it. Okay, so a lot of the words you can get without it, but if you want the 100%, you can probably look up ones you don't know. All right, so we're looking for table of contents. Remember, this should have been copied onto pages 2 through 6 of your composition book a long time ago. If you haven't done it already, please stop what you're doing and copy it in. See the videos of how to number pages / videos of A comp books, etc. Here we are in Equations Review. This is a unit. We're way down on lesson 9, Rewriting Equations and Formulas page. It goes on these page numbers of your comp book. Please don't take this video's word for it, but go back and find the original table of contents. By the time you watch this video, these page numbers will probably be different. The notes are here, the problems, and the video solution will be here once it's posted. So we're going to go to notes. Fair warning, you might have to load it twice to get it to load. This one just happened to load the first time. Take these notes in your comp book. You'll either see a picture of my notes or a picture of the board, if I had had a chance to write them on the board or not. Please follow these, and now I'm going to go through the problem sets. It talks about circle, those equations, and triangle, and rectangle, and what else? Equation solving. And with that said, since it's the 9th lesson of a review unit, right, on equation solving, I'm going to move ahead with some idea that this probably looks a little bit more familiar to you than if we were just starting from scratch, right? So given the area of a circle, formula, area equals pi r squared. So what do we have? We have area equals pi r squared. An oldie but a goodie, right? It says solve for r. So notice right now it's solve for a, right? We want to solve it for r. What do? We use equation solving to move everything away from and isolate the r. What is, I had a teacher would be like, what's bugging the r, right? And well, the pi is, right? So it's being multiplied here. What's the opposite operation? Let's divide both sides by pi. Pi over pi is 1. So notice it's already disappeared from the right. The right of this thing is now cleaned up a lot. It's only r squared equals a over pi, excuse me. What's the reverse of a power? We need a square root. What we do to one side, we do to the other. So a square root of a square disappears, and I'm going to flip this. I'm going to move r from this side to that, and this over here. R equals square root of area over pi. We just solved this for the radius when prior it was solved for the area. So radius equals square root of area divided by pi. This one right here. Remember, this is the square root symbol when it's typed in the computer. There's some other misleads here, but nothing really close at all. So, this one's kind of just trying to lead you down the path of coming up with the right answer, and then maybe even you can go back and figure out why that's the right answer. All right, given the same thing, area of a circle is pi, we're using diameter now, d over 2 squared. So remember, if this is a radius, and radius is equal to diameter divided by 2, then we could replace the r here with diameter divided by 2. They want us to solve for d. So let's go through the same process. We are going to divide both sides by pi. that disappears it from the right. So now we have d over 2 squared equals a over pi. What's the reverse of a square? Square root. What we do to one side, we do to the other. This disappears. Okay, come up over here. Now we have d over 2 is on the right equals radical or square root a over pi. Right? Last step, let's multiply both sides by 2 here. Draw a line there so we don't mix those up. The 2's cancel, and I'm going to flip sides. D is now equal to 2 times the square root of a over pi. So D is equal to, diameter is equal to 2 times the square root of area over pi. Pretty cool, right? So this is just rearranging formulas. That's the name of it. It's called rewriting equations and formulas. So given an equation or formula, we can rewrite it to solve for an unknown. Let's keep moving. Given the circumference of a circle is c equals 2 pi r, solve for r. Divide both sides by 2 pi. The 2 pi disappears and you're left with r equals c over 2 pi. Radius equals c over 2 pi. Oh. Doesn't look that easy when you start, huh? But sure looks easy once you're done. All right, so if c equals 2 pi r, we know that there's 2 radiuses in a diameter. So c equals diameter times pi is another way of saying circumference if you have a diameter. We want to solve for d. Well, divide both sides by pi. This is a one-step equation, by the way. C over pi is your answer. Diameter equals c over pi. Given the diameter is 2 radius, so now we're even going back. Diameter equals 2 r's. Okay, this is, going to be a one-step. You want me to solve for r? Fine. Divide both sides by 2. R equals d over 2. Or I could write r equals d over 2. Sorry, it keeps popping up. R equals d over 2. All right, radius equals d over 2. No matter what you're given, as long as you only have one unknown, we can rearrange these formulas so that you can solve for the unknown you need. Given that the area of a triangle is, all right, so you guys remember base times height is a rectangle, right? But a triangle is 1/2 of a rectangle. So if area was base times height for a rectangle, if you want to know this triangle here, all we have to do is half base times height. Cool, right? So they want to solve for base. We want to solve for b. So I might say this. Let's multiply both sides by 2. And that cancels the 2 from the right side. Now we're left with BH equals 2a. We want to solve for base, so let's divide by h on both sides. The h's disappear because h over h is 1. 1 times b is b. And we now have b equals 2a over h. 2 times area over h of this triangle. Okay, so base equals 2 area divided by h. Given that the square area is side squared, so area equals s squared. Solve for s. Well, take the square root of both sides because that's the reverse of a power 2. S is now equal to the square root of the area of the square. All right, and just make sure we're talking about what shape we are. So it would be area, and sometimes they'll put a square down here. Like up here, they might have put area of a triangle here. Little things like that help you remember exactly what we're talking about. So given the area of a trapezoid, solve for B1. Area equals B1 plus B2 over 2. We're going to put a parentheses to group it times H. Solve for B1. We want that right there. Well, let's do this. Let's multiply both sides by 2. That gets rid of the 2 here, and it shows up now on the left side of the equation. Let's divide both sides by an H. Now the h's are gone from here, and it shows up over here. Now let's rewrite it. B1 plus B2 equals, notice I can flip sides of an equation as long as I fully flip it. 2a over h. Right, that's what I've got so far. I want to solve for B1, so I'm going to subtract B2 from both sides. Gone. So in our final form, We have b1 equals 2a over h minus b2. Barely. There we go. Sorry about that, you guys. So 2a over h minus b2, right? And I didn't circle this one up here. This was s equals square root of a. There we go. All right, we'd like to put a fence up around a rectangular backyard. We know that the length of the backyard is 10 feet and its area is 150 square feet. Fencing is 300 per foot. Find the width of the backyard. So they tell us it's a rectangle, correct? We know that the area of a rectangle is area equals base times height. They then say the length. Okay, fine, length, you guys. Length times width. And you should know that length or base and width or height are the same dimensions, just with different names. And we've had different practices on that. So let's say LW. So they're giving us the length. We want to know the width. So if area equals LW, we want to divide both sides by L. It'll disappear from here, and we're now going to know that W equals A over L. So they gave us the area is 150 divided by the length, which is 10. And I appreciate they gave us nice numbers. So width is 15 feet. That means, just to go backwards to confirm, they gave us length 10 and width 15. Now, does it bother you that one was longer than the other and we called one length and width? I hope not too much, all right? Maybe a little, because we could easily just draw this over and go, let's call this 15 and this 10, all right, just the way I drew it. It doesn't matter. You're going to multiply one by the other and you're going to come out with the same. So we have 15 feet. Now, here is the same question they're asking us. We'd like to put a fence up around the rectangular backyard. We know that the length of the backyard is 10 in this. So fencing costs 300 per foot. How much will it cost? Well, how much will it cost? Fencing costs 300 per foot. So I think we want a fence in this backyard. We've got 15 here, 15 here, 10 here, 10 here. Is this right? I'm not totally sure. Let's see what I get, right? So we'd like to put up a fence around a backyard. That's perimeter, so I'm going for perimeter here. We know the length of the backyard is 10, and it's 150, so it's got to be 15 wide, so it's 10 by 15. I think the perimeter is 15, 25, 40, 50 feet. It's 50 lineal feet, or length, and it's $300, so we're going to multiply by 300. Right? I'm not sure I like my answer choices popping up here. Let's see here. There we go, there we go. Finally, let's do 50. Clear? 50 times 300. So I see 15,000 as my answer here. Not totally sure what they were thinking. Okay, and it does say 300 per lineal foot. I'm just curious, what if it was 4,500? 4,500 divided by 50, 4,500 divided by 50 feet equals 90 bucks per lineal foot. I'm tempted to change this to 90 bucks, okay, so that it can be this answer. And therefore, let's just check. This is 30, 40, 50. I like that for a perimeter. And so if we made this $90 per lineal foot, then we could go ahead and use their answer of 50 times 90 equals $4,500. Sounds a little bit better for the price of a fence anyway, if you ask me. 15,000 seems a little expensive for fencing a 10 by 15 backyard. Even 4,500 might seem expensive, but let's go with that. Okay, make sure you are matching up the title. So you are matching the problems you are practicing with the video you're watching as solutions, right? This is Algebra 1, Semester 2. It's the 5th unit called Equations Review. It's the 9th lesson called Rewriting Equations and Formulas Practice on CreatorMath.com under the Algebra 1 tab. Hope this helps.